In this video, we're going to end up with a trig sub integral here, but we don't see it maybe right away because it doesn't match up because of this extra x. So what we're going to need to do is use a technique called completing the square under the radical to get things to work out. So let's go through that and we'll come back and see if we can find any of our substitutions. So under that radical, we need to complete the square, and I'll show you a way of going about it. I'm going to factor out a negative because I always like my x squared to have a positive term. So x squared minus 4x. So I'm going to complete the square on that part in the parentheses. So I have x squared dx times, now I got the negative outside. Don't worry about that. I know it looks like a negative under the radical, but what's in the parentheses can come out negative, so that's okay. Now I'm going to have x squared minus 4x plus something minus something. Now what we need is for this part here to be a perfect square. In other words, it's going to factor into two identical factors. Now remember how that works. You know, if we have two identical factors there, they're going to look like this. They'd both be minus because of the minus 4. And these two terms, you know, this would get multiplied by here, and this would get multiplied by here. They're both going to have to be negative 2 because we got a negative 2x, and a negative 2x gives us our negative 4x. Multiplying those together gives us a positive 4, so that was the missing number. I added that in, so I have to subtract it right back out. So there is my perfect square. And what it factors into is x minus 2, the quantity squared. So coming over here, we got x squared dx over square root. We have the negative, we'll deal with that here in a second. Now that first part becomes x minus 2, the quantity squared, minus 4. Now, in order to identify our substitution, I am going to distribute this negative over the parentheses. So x squared dx all over the square root of 4 minus x minus 2, the quantity squared. Now let's bring that sheet back and see if we see a trig sub that kind of matches up. Look at now. Notice we have a constant minus our x piece squared. So it looks like sine will be our best option. Now what we're going to do, instead of letting just x be a sine theta, we're actually going to sub out the whole x minus 2 to be a sine theta. And in this case, a is going to be the square root of this number, because notice it's a squared. So it'll be 4. Alright, if you watched any of my previous videos, what I always say is, as soon as you find x, find your dx. You do not want to forget about it. So that's going to be 4 cosine theta d theta. Biggest mistake I see in trig substitution is that people forget about the dx. Now let's substitute everything in and see how our integral looks. Now first off, notice it was x on top. So if x minus 2 equals 4 sine theta, then x equals 4 sine theta plus 2. So that's what's going to go in for that one on top. I apologize, I have a mistake here. I'm going to fix this. It should not be 4 sine theta. You guys probably already caught it. That should actually be 2 sine theta. So we'll get this fixed and go back and getting this thing done correctly. 2 sine theta, because it should be the square root of 4. So even we make mistakes. Okay, so let's plug some stuff in. So first off, for x, we have 2 sine theta plus 2, the quantity squared dx on top. But we're subbing out our dx, so let's go ahead and get rid of that. Dx, which is 2 cosine theta d theta. All over, on bottom, we have the square root of 4 minus, now remember, x minus 2 is being replaced by 2 sine theta. So 2 sine theta squared. Alright, now we got a little bit of simplifying to do and see what we get. So first off, remember why we do this. I'm not going to multiply this out yet. Let's see if we can, how easy we can make this thing before we have to deal with this. 2 cosine theta d theta all over. I'm going to have the square root of 4 minus 4 sine squared theta. So we have 2 sine theta plus 2 squared, 2 cosine theta d theta. I'm going to pull the 4 out and pull it out of the radical. So I'm going to end up with 2 times the square root, because pulling the 4 out of a radical, we're going to take its square root. 1 minus sine squared theta. And now you can start to see the value of our trig sub. So we have the integral of 2 sine theta plus 2 squared, 2 cosine theta d theta, all over 2 times the square root of cosine squared theta. Square root of cosine squared theta is just cosine theta, so those cancel. The 2's cancel. So what we get is 2 sine theta plus 2, the quantity squared d theta. Now in order to solve this, we're going to need to multiply this out. So foiling this out, we get 4 sine squared theta plus 4 sine theta, 8 sine theta plus 4 d theta. We're going to be able to break this up piece by piece. Thing is, dealing with a sine squared theta, not really straightforward. Either you can use the tables of integrals, or you can use a trigonometric substitution. So we're going to use a double angle identity that says that sine squared theta is equal to 1/2 times 1 minus cosine of 2 theta. So we're digging back into your trig there a little bit using this identity. So 4 times 1/2 times 1 minus cosine of 2 theta plus 8 sine of theta plus 4 d theta. We can do some canceling there, and I'm going to now distribute that 2. So I'm going to have the integral of 2 minus 2 cosine of 2 theta plus 8 sine theta plus 4 d theta. The 4 and the 2 can get added together. Always do as much simplifying as you can before the antiderivative. You never know when things are going to cancel, and you might make things just a bit easier on yourself. Alright, what do we got here? Now we start taking the antiderivative piece by piece. This is going to be 6 theta minus, this will be 2 sine of 2 theta, now by chain rule, over 2, so those 2's are going to cancel. And then this, the antiderivative is negative cosine, so we're going to end up with a minus 8 cosine of theta plus c. Alright, now we are almost done, but remember, we want to get this thing back in terms of x. So let's go back to our original substitution. We know that x minus 2 equals 2 sine theta. So we're going to use that piece of information, and we divide by 2, and I like making a right triangle. It's not the only way though. Here's my right angle. I'll call this one theta. Sine is opposite over hypotenuse, so the hypotenuse is 2. The opposite side would be x minus 2, and so the adjacent side is going to be the hypotenuse squared, so 4 minus x minus 2, the quantity squared, which if you simplify, oddly enough, interestingly enough I should say, becomes the square root of 4x minus x squared. That should look familiar from our initial problem. That happens quite often with trig substitutions. Okay. So that means we know that sine theta is x minus 2 over 2. We know that cosine theta equals square root of 4x minus x squared over 2. We're going to use that to put this back together. Unfortunately, with theta, there's not a whole lot we can do besides use an inverse trig function. So, remember we know that sine of theta equals x minus 2 over 2. So theta equals the arc sine of that. X minus 2 over 2. So we'll try and put this back together if we can. We might need to go onto another page. So we're going to have 6 arc sine of x minus 2 over 2. Now sine of 2 theta. Notice we don't have sine of 2 theta. We can't just double one of these. So we are going to have to use the double angle identity for sine, and we'll substitute in the next time. Sine of 2 theta is 2 sine theta cosine theta minus 8 cosine theta plus c. And now we'll substitute. We could have substituted for that cosine theta there last time. Let's get it all back in terms of x though. So we have 6 arc sine of x minus 2 over 2 minus 2. Now sine theta is x minus 2 over 2. Cosine theta is square root of 4x minus x squared over 2 minus 8 times cosine theta, which we just said is square root of 4x minus x squared over 2. And finally our plus c. There's not a bunch of simplifying we could do. We could cancel out one of these 2's with this 2. We can cancel out this 2 and make this a 4. So we can do a little bit, but not a whole lot. Put my hand on that. And there, not a pretty antiderivative, but we were able to find the antiderivative by hand of our original function.